If I see someone selling penguin poo, I should make sure it's from a reputable source and it's legally
Exactly, for
done.
somebody with an export license.
Okay.
You're listening to the Cosmic Cast.
Hello everyone, and welcome to another episode of the Manchester Group's Earth and Solar System Cosmic Cast. You're here with me, proprietor of the phrase, "Don't worry, I'm Ricky Bahir." To my left, there is a parrot among the pigeons, Dr. John Pernett Fisher.
Hello.
To my right, the economically viable Tom Harvey.
Hello.
And we have a real guest for you all today. And I know I always say this, but I'm getting emotional. It is the ever joyful and always a Catherine, Dr. Catherine Joy.
Thanks, Ricky.
How are you doing?
I'm fine, thank you. How are you?
How are you, John?
I'm pretty good, thanks.
And Tom?
I'm doing all right.
And I'm very well, thank you.
Good stuff.
Do you think of those on the fly? That's very impressive.
Don't break the fourth wall, John. So, Katie, I think it's always best to start this by letting the people know just a brief synopsis of who you are. So, obviously, you work here at Manchester University.
I do. We're sitting in my office right now.
We are sat at the fourth wall, Katie. The wall, don't break it. So, you're a lecturer here?
Yes, I'm a Royal Society University Research Fellow, which means that I get funding from the Royal Society, which is a charity supported by the government down in London to do research. And I'm paid to do investigating the moon's geological history and specifically its impact geology history.
Not only do you work and lecture and study the surface of the moon, you've also recently been down to Antarctica.
That's correct, yes. So in addition to the research I'm funded for, we also tend to get involved with lots of other projects when you work in academia. And I got sucked into a really exciting project working with my friend Jeff, who is in the School of Maths here. And we sort of actually, this is a project that started in the pub, which is where all science should start.
Indeed.
In that we were having a bit of a chat about Antarctica and meteorites. And Jeff's been thinking a long time about debris-covered glaciers and how glaciers that have rock on top behave differently under different lighting conditions to those that aren't debris-covered. And he'd heard of the fact that we go to Antarctica to collect meteorites, and we were chatting about meteorites, and then we got into a whole discussion about collection statistics of the types of meteorites you find in Antarctica compared with everywhere else in the world. And this is a known kind of statistical anomaly. The types that we find in Antarctica have less iron meteorites than the stony types. So these are some of the main classification groups of meteorites. And anyway, Jeff, being a mathematician into his statistics, got all excited about this, and we went off and we tried to demonstrate why this difference could possibly exist. And then we managed to secure some funding, and one thing led to another, and suddenly I found myself in Antarctica. So a bit of a long story cut down short, but yes, I've just got back about 2 weeks ago.
And how many times have you been now?
This is the third time that I've been to
Wow.
Antarctica. So I've been twice before. I went down with an American meteorite hunting project called ANSMET. They've been operating since the 1970s. They invite international scientists to join them on some of their expeditions. And so I've been lucky enough to be supported by them twice, which was amazing. And then now we're doing this new project, which is the first time is a UK-led Antarctic Meteorite recovery program. So we're really proud of the fact that this is the first time in the UK we've been financially supported through a research grant, and it's the first time that the British Antarctic Survey have facilitated the logistics to get people to Antarctica, which is, a real step, a real move forward. And now we've done this once. We've demonstrated that actually there are meteorites in the parts of Antarctica that BAS can get us to. This provides a real opportunity for the future to continue this as a new research program.
Something that just on an overview level, people who are listening might not fully understand is why do we find meteorites in places such as Antarctica and also like desert-like areas of the planet?
Yeah, great. No, that's a really good question. So we have about 60,000 meteorites that have been recovered all across the world, and that's based on meteorites that exist within a database that have a name. So there's probably more meteorites. Sometimes people don't bother to get a name for them, but of those 60,000 meteorites, about 35,000 have been found in Antarctica. Now that doesn't mean that they more fall in Antarctica than anywhere else. Actually, probably more fall towards Earth's equator, to do with the way that they're kind of gravitationally attracted to the Earth. But the ones in Antarctica are easy to find, black rock sitting on white ice. They're very well preserved. If a meteorite falls here in the UK, they disappear into a forest. They're quite hard to find. They tend to get eroded by water and rain, and they sink into the mud. In Antarctica, it's essentially a dry desert, so they don't get altered very easily. And in Antarctica, we have this concentration mechanism whereby, although they fall all over Antarctica, the ice is funneled up through its natural transport to the coastal areas, and then when they hit a mountain range, the meteorites sort of are projected upwards where they emerge at the surface. And so we can go to certain areas of Antarctica, they're called meteorite stranding zones, where you can find tens to hundreds of meteorites within a few hundred meters to kilometers. So they make an ideal collection ground to go and recover these samples from.
So is it quite good luck then that some of the British bases are near some of these areas?
Yeah, actually, the British bases are frustratingly quite far from these areas. So that was one of the major challenges we had with the project, was to work out where we thought were good areas where meteorites could be concentrated. That was sort of step one. They tend to be in regions that are called blue ice areas, a very slow moving ice close to topographic highs. They tend to be close to the polar plateau, so where the ice kind of comes off from the South Pole. And both those areas are actually quite far from the main British Antarctic Survey base, which is called Rothera, which is on the Antarctic Peninsula, kind of up underneath Chile. We do have another base on the Antarctic continent called Halley.
Is that the one that's on skis?
It is the one on skis. It's so cool. It's sort of further to the east than Rothera. It's on the Brunt Ice Shelf. It's actually sitting on ice which is overlying the ocean. So it's in quite a precarious position, and there is this is actually Halley 6 is the one with skis. There's been 5 Halley bases before that have all disappeared off and kind of drifted away and have been lost. So Halley 6 is designed, because it's on skis, to be able to be towed and moved to a new location. And so when there's a potential issue with an ice crack that forms, there's a lot of logistics that go into it. There's a great BBC Horizon documentary you can watch where they drag this base on skis and they reposition it. And that happened 2 winters ago, which fortunately it did, because there is now a big crack quite close to Halley opening up, but they've moved it to a relatively safe position. So we flew. To get to Antarctica, we flew to Chile, we flew to Santiago, we flew right down to the bottom of Chile to a place called Punta Arenas. We got on an airplane, we flew down to Rothera, that's about a 5-hour flight. And then after a little bit of time in Rothera, we spent a few days in Rothera, and then we had 3 flights that got us all the way over to Halley. Spent a bit of time in Halley, which was amazing, and then went out to the field from there. So our field sites are about 600 kilometres south of Halley, which is about a 3.5-hour flight in a tiny little aeroplane called a Twin Otter. So pretty remote, difficult to get to, and this is probably why BAS have not really done this type of fieldwork before. But there has been geology fieldwork done in this area and glacial research done in this area, so this is why we knew that they could get us there.
And what are the rules in terms of who can actually go there? So no one can just willy-nilly go down there and look for meteorites, surely?
No. So in Antarctica, the Antarctic continent is protected by what's called the Antarctic Treaty. And this means that it's primarily used for scientific research. And if you want to remove anything from Antarctica, be it a rock sample, a bit of ice, penguin poo, a penguin, whatever you need to remove, you have to get permission from your local government authority. So
if I see someone selling penguin poo, I should make sure it's from a reputable source and it's legally
exactly,
done.
for somebody with an export license.
Okay.
But you can't. Well, actually, no, you can't sell anything. That's the whole point. So Antarctica is there not for profit. That's the point of the Antarctic Treaty.
There are no gift shops.
There are gift shops, but that's stuff that they brought in and then resold, all branded with your local organisation or base. Exactly, local craftsmen. But no, stuff that's natural to Antarctica is really protected, and we had to go through quite a heavy organising for permits for removal, which were approved by BAS and then approved by the UK Foreign Office. So it's quite a long process, and you have to demonstrate why you're going, and you have to demonstrate, you'll conform to environmental regulations in the field. Tourists do go to Antarctica, and Antarctica is really opening up for tourism now, both in terms of cruise ships that go through, and also you can actually get to the interior if you have enough money, and you can even get to pole if you have enough money. It's one of these things that very wealthy people do. You can ski, you can go there and you can do expeditions where you ski across the continents as well. So Antarctica is opening up for more people, but to do the types of scientific research as we did, you need a lot of permissions to be able to go there.
You sound very positive about all of that, all the tourism and everything.
I think that it's a good thing that people see these environments and appreciate them, because frankly we don't know how long
they're going to last.
A lot of the Antarctic areas are going to last, and there are a lot of glaciers that are retreating. There's a huge amount of scientific study going on into a glacier at the moment called Thwaites, which is in the western part of Antarctica, which if that thing melts is going to add about 80 centimeters of ice to the water to the global sea budget. So people going to Antarctica are typically people that are responsible and want to see it in its natural pristine state. And I think as long as that environmental impact is managed effectively, I think that it's a controllable thing. Only so many people can go there, and so it's a positive for people to see that it's an incredible place.
I wonder if you could give us, and I don't know how much information you're allowed to tell us about this, but a day in the life then. So you get there, you've settled in. What's a day in the life of being down there? Yeah,
so when we get to the field, in this particular trip, it was myself and a field guide, an amazing woman called Julie Balm, who has worked for the British Antarctic Survey. She's worked for them for a few years. And when we get to the field, the first thing you do is do a lot of digging. Oh my God, most of Antarctic field work is just digging snow. So you dig your tent in, you put the tent up, which is an orange pyramid tent.
Is it freezing out there?
It really depends. So some days it was around 0 degrees, and it was warmer than it was in Manchester. There's no rain, there's no moisture, so it's incredibly dry. It can be minus 20 and it can still not feel that cold because if the sun's out, there's a high albedo. It's not too bad. But it can be 0 degrees and blowing wind and be absolutely freezing. So it's the moment the wind gets up, it's a complete nightmare. But you put your tent up, and that protects you from blowing snow and the wind. And inside the tent, you have the sleeping bags, and you have a cooking equipment, which also heats the tent. And we have a tilly lamp to keep us warm. So normally we woke up at around 7 a.m., which is frankly way too early for me. I'm not a morning person. And then normally it was Julie, because she was always awake before I was, would put heat the tent up, getting things warmed up a little bit. And often we would she would go outside the tent and see what the weather was looking like, because we'd have to tell Hallie if the weather was good, if it was bad, what the wind was doing, so that if there was any issues with flying for aeroplanes, they knew what the conditions were. After taking some weather, we would have breakfast, porridge, muesli, that sort of stuff, lots of high energy food, cup of coffee, tea, and then we would go out to work. We'd get dressed. Typically, I'd wear about 5 pairs of trousers, through from long johns up to like a down layer, and then like a ski salpette, and then on top probably about 5 or 6 layers as well. Down again from a thermal vest layer through to several thicker layers, a jumper, a big windproof jacket, and a down layer. So we put all of that garb on, big boots. You get out the tent wearing your sun cream because the sun's very strong, so you don't want to burn. And then we'd put on our climbing racks. So for those of you that go climbing, this is basically a harness with bits of metal equipment. And that's a safety thing. So if we ever fell into a crevasse, the equipment that we'd wear would be used to be able to get ourselves out again. So we could kind of prosic, which is kind of raise yourself up a rope, or you could set up a safety line to bring the other person up.
So with that in mind, do you have to go through training before you go then?
Yeah. So when we got down to Rothera, Julie, who's the field guide, goes through a lot of this training and demonstrates how you can rescue somebody from a crevasse and rope skills and things like that. And knowing the emergency procedures. We also have first aid training before we go down to Antarctica. We have a 2-day intensive field first aid course, where they teach you kind of the basic medicine stuff to deal with an emergency. Thank goodness we didn't really have to use any of that knowledge, but it was useful and terrifying to know the types of things that could possibly happen. So you always keep that in mind, safety consciousness. So you put your safety equipment on. you go warm your skidoo up. So we drive snowmobiles. We have one each, so you have to make sure the engine's fine and running well. And then you load your skidoo up with your emergency skidoo.
I love that.
I know, the do, as they call it.
Oh,
You load
in
your
the
do
tray,
up.
They call it the do. Hey guys, we need to go get some penguin poo. Get your skidoo.
And then we would go to, we'd get all the equipment on, and we would travel out from where we had our camp into the field. All this is quite a lot of faffy time, so it normally takes about an hour to kind of get ready to go. And then when you're ready to go, we drive out to the field site in what's called a linked travel. So Julie would go off first on her skidoo, and then and then there's a sledge kind of dragging field equipment, and then there would be me behind, and we'd all be in a long line connected with a rope, so that again, if there was any kind of safety issues, we would be protected along a control system. We get to the field that we wanted to go to. Sometimes we drove for about 10 minutes. Sometimes we drove for 30 minutes. One day was like an hour and a half. And this is all over quite rough ground with big snow mounds that we called sastrugi. I think that is an Inuit word for these kind of snow peaks. So it's sort of a little bit like riding. The skidoos are really comfy. They're kind of like big, beefy motorbikes. But some days it was a bit like being on a bucking bronco, and you're driving along and you're bumping all over the place, trying not to let go of the skidoo. And then when we get to the field, we disconnect from the safety system, and at that point we're meteorite hunting.
Yeah.
And we just go. So we sort of drive across the blue ice, which is incredibly bumpy. It has these scallops in the surface, and so you're sort of rattling across. And then when you do that, you're looking side to side, and you're trying to spot black rocks.
Literally just looking out for them. Yeah.
On this particular trip, we were literally just looking for things that weren't ice.
Yeah.
So every time you see a rock, you'd get off your skidoo. Sometimes it would turn out to be earth rock, and so you'd kind of recognize what the local rock was like that had blown off the local mountains. But more often than not, in the places we went, they were typically meteorites.
Wow.
And then when you spotted something, you'd call the other person over, and then we go about collecting that sample. As
you said, this is the third time you've been out there. Do you feel jaded to it now, or do you still get extremely excited every time you see one?
They still get excited. Yeah. Oh my God. The feeling when you spot a meteorite is awesome. Yeah. It's a little bit of an adrenaline kick. It sounds strange. You're there to do this as your job, but especially when you see a cool looking one, especially when you see one from like 30 meters away, because then you're like, yes, this is going to be big. Or you can, as soon as you get off the skidoo and you look at it and you think, that's quite different to things we've seen before, and that's exciting as well. So I'd say, pretty much every meteorite we found was a really awesome feeling. You kind of get a bit addicted to it after a while.
So presumably on some days you find more, and on some days you find less. How do you kind of keep the morale up as you go to kind of continue looking? Yeah,
that's a really good question, because you're in such a remote environment, and it's quite it's a very different experience from being at work normally. And you're absolutely right. On a day you don't find any meteorites is incredibly frustrating. You're working really hard. It's physically exhausting to stand up on this skidoo all day. It's physically exhausting to be out in the cold. Sometimes you aren't eating as much as you should do, because you're sort of trying to you just plow on basically. And if you get to the end of the day and there's no meteorites, that's sort of one of those mental check things that's difficult. But then you sort of have to think of, well, tomorrow will be a better day type of thing. So some days, one of us didn't find any, or the other one wouldn't, and you just kind of have to balance it out, thinking, well, tomorrow it will be redressed by the other person finding a few more. It's a strange sense of ploughing on, and especially when you're wearing your face mask, which you wear all the time to protect you from the wind. It's quite insular. So you actually are quite in enclosed space, even though you're in this huge empty environment, you're in quite an enclosed space. So sometimes you just have to stop and sort of shake your head and think, remain focused on what you're doing.
If you spend most of your day meteorite hunting and you had an off day, are there things that you can do around the camp to kind of help cheer you up again, or do you just go straight to sleep when you're done?
Yeah, we normally have a lot of hot chocolate. So that's a good question. So if you have a day, or for example on this trip, when you have a bad weather day and you can't get out of the tent to go and work, or you go out and then you don't achieve as much. So what we would do on those sorts of days or in the evenings is every night when we got back to the camp, we phoned back with Hallie, the people in Hallie, the operations team there. It was our scheduled phone call, and for them it's a way to check that we are okay. If we don't phone in, then they know there's a problem and emergency procedures kick in. But that phone conversation for us was a really nice thing in the evenings, because we got to speak to, I think there was about 4 of them on the base. There was Rich, who was the base commander, Barney, who's the science lead, Alan and Sarah, who were the comms leads. And that was so lovely because you got to hear somebody else's voice and you could build up a bit of a rapport through talking with them and listening to their stories. And they tell us jokes and generally
And had you
try
met
to make
them
happy.
before?
Yeah, so
Okay,
we'd kind of met them go, yeah.
Yeah, right.
So that was a nice sort of thing, something you look forward to in the evenings, which was a procedural thing, but also it was a nice way to sort of feel that there were other people out there. And then occasionally they would come and resupply us or move our camp. And our pilot, who flew the Twin Otter, who is an amazing woman called Vicky, would come in, and we'd also get a co-pilot come in from Halley as well. So we did see quite a few people during the field season that we could kind of catch up with.
Is it quite difficult to adjust to such a white landscape? Were you gagging to see some green after a while?
Yeah, you miss certain colours, certainly, and you miss topography. It's very difficult to judge distance and to gain that idea about that space that you're actually in.
Must be really reliant on GPS, I guess, to navigate.
Completely. Yeah, you look at a hill and you think, I could walk over to that, and then you suddenly realise it's about 6 kilometres away, and that's probably not quite a good idea. But yeah, adjusting to being in that environment takes a while, and then it's almost much more difficult to then adjust back because you've been living this quite a different lifestyle than you'd normally live. And I think that's a really hard thing, is when you come back out of Antarctica, getting back to all the normal stuff and paying for things with money again, my word. And
you were out there for
I was out there for in the field we were out there for about 4 weeks, and then in total about a month and a half.
So 4 weeks of essentially doing the same thing every day.
Yeah, exactly. Or sitting around in the tent not doing a lot.
Yeah. I guess sitting around the tent days must be the hardest days though.
Yeah, you're kind of wanting to work and you can't. It's quite frustrating.
I mean, that's the academics problem, isn't it? What is a weekend?
I read a lot of books, and we did have a laptop, so we do take it as a little generator, and you can power your laptop up. So we did watch some movies and things.
Okay, so you're back now. You made the journey. You've been back a little while. Could you tell us a bit about what we can expect? What did you find?
So when we first went into the field, we didn't really know what we were going to find, and that was always the risk, which is why this is a reconnaissance mission to Antarctica, to see whether these ice fields that have never been visited before actually were meteorite bearing. So the number one thing we found was meteorites, which is good news.
Fantastic.
I know we didn't find any on the first day, so it was a little bit down that day. But the second day we found 3. And from there on in, we continued to find pretty much 1 every day we went out and worked. One day I think we found 8, which was amazing.
Wow.
But we got in total 36 meteorites, I think, through the whole field season. I probably did collect a couple of non-meteorites as well, but I'm not counting those in the official number. So we found a range of samples in size varying from a couple of millimetres up to the biggest one was about 20 centimetres.
Can I just ask, before you go into a detail about the actual samples, what is the step-by-step for actually determining something as a meteorite, other than just it's a black rock?
Yeah, so in the field, we recognise them because they have a certain colour to their exteriors. They have a black fusion crust, as you say, or they just look very different to the local terrestrial rock. So you're right, at the point of collection, we can't 100% guarantee that it's a meteorite, but through being familiar with what meteorites look like, I'm pretty confident that they are. So
for those who don't know, a fusion crust is, as a meteorite is falling through the atmosphere, it burns the outside of it, and that is what we call the fusion crust, that burnt exterior.
Completely, yeah. So we lose about 1/3 of the meteorite during that entry phase, and that burning of the exterior the colour really depends on the type of meteorite. So some meteorites have a very black fusion crust, some are kind of a chocolate brown, some are even a weird green colour. It's really strange. So it depends on the type of meteorite, whether it's come from an asteroid, what type of asteroid, if it's come from the moon or Mars, as to what colour they go during that entry event. So when we find them in the field, we sort of can look at a meteorite and go, well, we think it's probably one of those. But you don't want to be 100% certain. We can do another little test as well. We can use, in fact, Tom's very familiar with this, we can use a magic device provided by our colleague Jerome Gatterchecker in France that measures the magnetic susceptibility and the conductivity. So basically how much metal there is in that sample and how that metal conducts electricity through the sample. And that gives us an indication about the metal content of that particular rock. And earth rocks typically can be magnetic, but they have low metal contents. Meteorites typically can have both metal and they're both magnetic as well. So we can use this device, take a measurement, and that gives us another rough idea, pretty good idea actually, about what type of meteorite it is. So I've analysed, Tom did some work before we went out there analysing some of our lab samples.
Yeah.
And we have a good index of those. So the one thing Tom's not going to say because he's too polite is you also have to base that measurement on the mass of the sample, and he knows how rubbish I am at estimating the heaviness of different rocks. So you put me through a training procedure.
Yeah, we were using the
clicker that we use for the numbering system. We knew how heavy that was.
Yeah, and the box
for
the device as well. We weighed them, and we're trying to figure out how much.
Well,
So using your hand.
it's a difficult skill. I mean, there's a reason why people do that as competition for raffles and stuff. It's not easy.
You should get
well, it's quite important in actually determining the output.
So
If
sorry,
you
the
don't
mass of the object.
The mass
is
of the
important,
object, yeah. Whilst you don't have to know it exactly,
Yeah.
it is quite important in ensuring that you're accurate.
Well, I watched Hell's Kitchen once, and Gordon Ramsay got the people to slice up a fillet in perfect 250 gram sizes. So you should bring a sous chef out with you next time you get them, and they can
Piece of steak.
yeah.
I like that. Well, I was still a little bit rubbish. So although I have those measurements, we need to check everything. So we'll do that when we get the samples back to the lab. But 36 of the samples we collected, I am pretty convinced are not of this Earth, and so we've put them in bags. They're in a special box, and we've kept them frozen. So currently they are still in Antarctica, even though I'm back, the samples aren't. And they're going to be put on a boat and shipped back to the UK as frozen packaging, along with some ice cores, samples that were collected by other science projects. And then in June, we get that box. We can unpack them one by one, and then we'll go through a procedure whereby we look at them in the laboratory in Manchester, and using the same techniques that we use for our research projects, such as measuring the mineral chemistry using electron microscopes. We'll probably measure the gas content. We'll send some to our material to our collaborators that work on different isotope systems like oxygen. We'll be able to write up a definition of what each meteorite is and put it within its class of meteorites. So, meteoriticists are kleptomaniacs, and we have these amazing classification systems for all these different types of asteroids and how those asteroids have been changed by water interaction or by metamorphism on their parent body. Also by how much they've been shocked by impact processes. So between us as a team, we'll classify them, and then we'll release that list to the community. And then people interested in doing scientific research on the meteorites, from not just from within the UK, but from anywhere in the world, will be able to get in contact with us, and we can share some pieces of our meteorites with them. So that's the long-term goal for the project, is to share the samples for planetary science research, the types of cosmic chemistry that we do in the UK really well.
Can I ask, what's the importance of keeping them frozen?
The reason we keep them frozen is because they've probably got water inside their pore spaces and from sitting in the ice floes in Antarctica. And we kind of want to control how that water behaves when it's liberated from the sample, so it doesn't alter or damage the sample. And so we'll freeze dry them, which is the sort of standard technique that's done to try and control that water loss. If we collect a meteorite from a hot desert, we don't really have to worry about that too much. But from Antarctica, it's a good idea that we keep them as pristine as possible.
So essentially to stop the water from altering the minerals.
Yeah, exactly. And there's other things that's like salts that are trapped within them. We don't really want the salts to suddenly start mixing with the samples particularly. So the other reason we're going to do it frozen is because we're going to go hopefully back to Antarctica. Well, we are going this year again. And the longer term goal of the project is this year we collected meteorites on the surface of the ice. The real long-term goal of the project, and this kind of goes back to the statistics question and what my colleague Jeff is interested in, is we're designing a technology for detecting subsurface meteorites. So meteorites that are trapped within the ice that are metal rich that we can find using metal detectors. And so what we'd like to do next year is bring back some, if we can find one of these ice-trapped meteorites, is to bring the whole thing back encapsulated in ice so that we can actually then make measurements of the ice as well as the meteorites. So this is almost a practice run for what we'll do next time around.
So just going back to what you said at the beginning then, so your hypothesis at the moment is there's very few metal-rich ones found in Antarctica because they melted into the ice then?
Yeah, so it's a complicated mechanism. So yeah, as you say, we have these stony types which have lower amounts of metal, and then we have the metal-rich ones, so the iron meteorites, and we have this amazing group called the palasites, which are a mixture of metal and silicate material. So they probably form deep within a planetary body, so towards the core mantle boundary. And we think that these metal-rich meteorites probably not necessarily sink into the ice, but they kind of, as they're sort of drawn up towards the surface by this upward motion of ice, they heat up within the ice. And then they kind of, relative to the upward flow of the ice, I'm wiggling my hands around, not this is useless for radio. There's an amazing animation of this on our website. They kind of like sink down into the ice as the surrounding ice is moving up. So that's the hypothesis. And there should be a certain ratio of those that sink within. We think they probably get stuck at about 30 to 50 centimeters within the ice to those that then pop out on the surface. The other side of that fence is this year I think we have probably found one meteorite sitting on the surface which is made of iron, which is exciting because it clearly demonstrates that we have some that have kind of counteracted this process, and there are other irons that are found in Antarctica, but again we'll have to check that when we get the meteorites back.
Couldn't
to
be
the lab.
possible that they've landed after the ice has been...
That's the other thing, exactly that. So we could have recent falls that have not gone through this mass transport mechanism, and therefore they've been delivered to those areas. Yeah, absolutely right.
So if the metal detectors turn up some sub-ice meteorites, that 30 to 50 centimeters of ice is presumably pretty difficult to get to them. What's the plan?
Yeah, so you should talk to Jeff about this. You need to get him on. It's quite well, we've gone through lots of iterations of how best to extract meteorites from the ice. And Jeff, actually, when he went down to Antarctica this year, he visited a different part of Antarctica to me. That was one of his main tasks, was to work out how we could extract any buried meteorites safely. And he thinks he tried a chainsaw, which was quite an exciting health and safety risk assessment experience. But it worked fine using a chainsaw to get some ice out. But we think we have a better way where we're kind of using an ice auger, so a little bit like an Archimedes screw type of affair, to extract a large area of ice from around the meteorite as well. So he's trialled both those methods, and we'll take both those bits of equipment next time around.
So how does out of the 36 that you collected, is that what you'd expect for searching for 4 weeks? How does it compare to other field areas?
Yeah, that's a really good question. So all these things are kind of dependent on the number of people, the ground covered by these search operations, and the particular area that you're looking in, so the ice catchment that's fed that area with meteorites, and these sort of all play off against each other. So we were 2 people. We were, we had quite a lot of tent time because of the weather, so I think we probably searched for just under 3 weeks in total. We need to kind of calculate the numbers of hours. So we're probably a little bit lower than other field trips to Antarctica. For example, sometimes they recover hundreds of meteorites. Even I think one year ANSMET got about 1,200. So we're lower on numbers than maybe I would have liked. However, considering we've been to these new areas, and there was 2 of us, and this is the first time we've done it, I think actually we've achieved quite a lot for the amount of time we spent there. And the thing I think I'm most proud of is the fact that we found what appears to me to be quite a good diversity of types. So we've got everything through from, I think, a couple of achondrites, so those that have come from really big asteroids, or maybe the moon or Mars, through to the iron meteorite types, and lots of chondrites in between. And we've also seemed to have found quite large meteorites compared to what I remember finding on my previous experience. So we've got quite a few that are over about 5 centimeters. So that's good, because it means we probably missed a lot of the smaller ones. And so when we go back to these areas next year, there's a good chance that we can recover a lot more that we may have missed on this first trip.
Right, so I think we should probably wrap up there. I know we've only really scratched the surface on what you do, Katie, because we only talked about your Antarctica trip. You're also obviously a lunar scientist as well, so we'll have to get you back on to talk more about that. And I think we should say thank you very much for having you on. Is there anyone you'd want to shout out, anything you...
Yeah, no, it'd be really great to take the opportunity to thank the other guys on the team that I'm involved with. So, Jeff is the PI of the project, and to say all the people in Manchester, Andy, who was did a lot of the work kind of looking into where we should go in Antarctica, and the guys that built the metal detectors from the engineering school. We should also thank the Leverhulme Trust, who funded our amazing project. They like risky interdisciplinary stuff, and I think we're a nice example of that. And most of all, I'd just like to thank everybody at the British Antarctic Survey, because they were just awesome. Getting us there, sorting us out for all the health and safety, keeping me going through 4 weeks, particularly Julie for sharing a tent with me and coping with that experience. She was an incredible woman. And Vicky, our twin otter pilot, who flew us all around Antarctica. She's phenomenal as well. And Jen, our flight engineer. It was really cool to do this trip with three, most of it was with three other women. So that for me was a really good thing. And just generally all the support from BAS, you don't realise, there's people that are doing all the planning for making sure the weather's okay, the chefs for creating amazing food, just all these people that work really hard, and probably on most of the science projects you never really get a chance to understand what their jobs are. And so that was for me one of the best experience working with all the people at BAS.
Right.
Fantastic.
Yeah. So once again, just thank you for having you on.
No problem. Thanks
and
a lot.
your Twitter is...
Oh yeah, so we do have a website, and you can, which I think you guys will link to.
Yep,
So
yeah,
go and
it's
explore
been-
that,
should do
and
that.
follow us on Twitter. And when we start classifying the meteorites, we'll put all that information out online. And when Tom and I start doing some fun science with it as well, we'll start sharing that with you.
Grand. Thank you very much. Thank you.
Thank you very much.